All right, you guys, today I'm going to add a layer onto our understanding of perimeter and area ratios in our similarity unit. So first up here, I'm giving you a statement. I'm saying that this rectangle more is similar to this rectangle cats. And the way that I read that statement, it shows me how the corresponding parts align. So M is congruent to C, for example. Those angles are congruent, makes sense, they're both rectangles. And we also see how our corresponding sides are related. So we know that the ratio of MO is to CA, just as OR is to AT, and so forth. Okay, we're given a scaled factor, and we're given an arrow leading from left to right. So that tells us that this figure right here is the old leading to the new. And that scale factor of new to old is 11 to 6. So the way that that helps us, that means that any side, if I know any side in this figure, I can apply the multiplier of 11/6. So I could take the side length over here multiplied by 11/6, and that would get me my side measures over here. I could do the same thing with perimeter. Okay, if I was going in reverse, if I was going from here to here, from right to left, then my multiplier would be the reciprocal of my scale factor. So it would be 6 to 11 instead. So if I know a side here, and I'm trying to get over here, I would multiply by 6/11 instead. So just keep that in mind. Okay, what I usually do is I shade in my new. So I'm going to be consistent and shade in my new shape here in blue, just so I can always see it as the directionality of old to new. And then this ratio, that means that all of my sides would be in a ratio of 11 to 6. I may not know exactly what my side measures are, but I do know that if I reduce down their ratios, it would be in a relationship of 11 to 6. So I'm going to go ahead and I'm going to label over here that this would be 11 to 6. Now again, I don't know that those sides are 11 and 6. I just know how they are related. They're related in an 11 to 6 ratio. All right. So now, as I move into part A, I'm saying, well, if AT, so if right here has a measure of 66, what is the measure of OR? Okay, so a couple ways that I could do it. I could build off of my scale factor. So I could say, okay, well, I know that scale factor I was given was 11 to 6. So if I start that way, I know that the 11 is coming from the figure on the right, and the 6 is coming from the figure on the left. So I want to be consistent in how I build my proportion. I'm going to always read it from left to right or right to left. I want to be consistent. So I'm told that my ratio is 11 to 6, just as if AT is 66, that would be to X. So I'm going to write it as 11 to 6 equals 66 to X. Okay, from here I can cross multiply, and I get 11X is equal to 396. Okay, from here I'm going to divide each side by 11. And I wind up with X equals 36. So OR is 36 units. Here is the other way I could solve that. So again, if I know that AT right here is 66, and I'm going in that reverse direction, right? I could have taken that 66 and multiplied by 6/11, and that would get me over here. So I can apply my scale factor, just keeping in mind my directionality. I can treat it as a multiplier, or I can build a proportion. You just have to find your comfort zone for this skill. All right, next up, perimeter. So if my perimeter of more, so of my small shape is 50, what is the perimeter of my big one over here? So first I need a perimeter ratio. And remember that perimeter is really just the sum of all of the sides. So if my sides are in a ratio of A to B, then the sum of all of the sides will still be A to B. So my perimeter ratio will stay at 11:6. All right, so if I build off that ratio 11:6, then I'm reading it from the shape on the right to the shape on the left, 11:6. I know that the perimeter of the small one is 50. I want the perimeter of the big one. So if I have it as 11:6, right to left, I need to keep with that when I stack my second ratio. So here I'm going to have to say as x is 250. So again, 11:6 as the perimeter here, x, I don't know it, is to my perimeter here, which is 50. Okay, so cross multiply, and I get that 6x equals 550. Divide by 6. Okay, reduce that down. That's 275/3. I could leave my answer like that, or I can make it a mixed fraction, which would end up being 91 2/3 units. Okay, I would also take that as a decimal. Just keep that in mind. And if you're going to give it to me as a decimal, give it to me in 2 decimal spots. So you would tell me that it was 91.67 units approximately. That is fine with me. All right. If the area now, if the area of cats, if this area here is 240, what is the area of more? Okay, so I need an area ratio. And my area ratio is always taking that scale factor and squaring it. So 11/6 squared. 11 squared is 121, and 6 squared is 36. So my area ratio is 121:36. So I can say that 121 is to 36 just as. Okay, so again, I'm reading it from the big shape to the old. So here, the big shape, 121 to the little one, 36. That's how their areas are related. Just as this area here is 240, so that's going to go on top. This area is what I'm solving for. That goes on the bottom. So here I have my 240 2x. So again, when I build a proportion, I just have to be consistent in how I read it from figure to figure. Do I want to read it from left to right or right to left? Okay, cross multiply. 121x equals 36 times 240, so 8,640. Divide each side by 121, and we're going to get 71. That's reduced here, so 71, I'm going to make it mixed, and 49/121, and then units are squared. So I'll take it as a reduced fraction, mixed or improper. If you gave it to me as a decimal approximation, that would be 71.4 square units. So build a proportion, be consistent in how you read it from figure to figure, or apply it as a multiplier. So if I know the area of more right here is 240, and I know that my ratio, my area ratio is 121:36, I could take that 240 and I could multiply it. So let me see, which one did I give you? I gave you this one. Okay, so this was 240. So if my ratio is 121:36, right, then my multiplier that I'm putting on the area of cats, the 240 here, would be the reciprocal of 121:36. So if I was taking 240 and I multiplied by 36/121, it would give me the same answer. Okay, so again, apply it as a multiplier or build a proportion. All right, next problem. So here I'm giving you two shapes and I'm telling you that they are similar, but I've given you different orientations. I've rotated one of the shapes a little bit. So now again, I'm paying attention to the directionality. My arrow leads from right to left. So this is my old and this is my new. All right, I have different sides marked and I'm not sure, since they don't have the same orientation, of how they align. So I really have to go back to my statement up here. Cobra is to tulip. They are similar. So let's look at OB for a moment. Where is OB? So OB is right here, OB. So that must correspond with UL, which is right here. Those would be corresponding sides. So right there, I can figure out my scale factor. My scale factor is the ratio of new to old. So 6 to 8, which reduces to 3/4. So my scale factor is 3 to 4. So if I know any sides here, I'm multiplying by 3/4 to find the new sides here. That would work for perimeter as well. If I know the sides here, then I'm going to multiply by 4/3 to get to my sides over here. Or I build a proportion. So let's find the other corresponding sides. I'm going to have to solve for LI first. So here's LI. I want that measure. What is its corresponding side? Here is LI. That would link up with BR right here. So those are corresponding sides. So if I want to build a proportion, I can say, if I read it from figure to figure, I can say that this shape here, left to right, let's say I go left to right, right? 3 to 4. I'm just looking at that scale factor reduced. 3 is to 4, just as 4 is to x. Okay, cross multiply. 3x equals 16. Divide each side by 3. Right, that's simplified improper. So if I want that mixed, I could say that it is 5 1/3. So x would be 5 1/3, or 5.33 recurring. I would take it like that also, 5.33. We'll just leave it rounded to 2 spots, 5.33. Okay, if you put a little bar over the 3, that would show that it is recurring, and that's fine too. All right, next I want CA. So CA is right here. CA. That would sync up with TP right here. So again, if I start with a 3 to 4 ratio, right, 6 to 8 is just 3 to 4. So 3 is to 4, just as I want CA to TP. So I'll call that Y, or I can keep calling it X, that's fine. I'm just going to switch my variable for a moment. Y to 7. So again, I'm just very consistent in how I read it from figure on the left to figure on the right, or vice versa if I choose. Okay, cross multiply. 4y equals 21. Divide by 4. That's fine. That is improper. If I make that mixed, that would give me 5 1/4. Okay, or I could say equals, because that actually will terminate, 5.25, 5 1/4. Okay, next, perimeter. Well, perimeter ratio will be the same as a pair of sides. So I know that my perimeter ratio will still be 3 to 4. So I'm going to build off of that. All right, so perimeter here to here will be in a ratio of 3 to 4. If I know the perimeter of Cobra, I know this one is 26, and I want Tulip, then I'm stacking it as 26 to x. So again, I just need to be consistent with how I stack it. So I went small, large, figure left, figure right. I'm just consistent with that. Cross multiply. and I get 3x equals 104. Divide by 3, and I would get 34 2/3. So 34 2/3 and units. Okay, decimal approximation is fine. Okay, now area. Area ratio is different. Area ratio, we take that scale factor and we square it. So 3/4 squared. The 3 gets squared and the 4 gets squared. So 9 to 16. That would be my area ratio. So if I start with 9 to 16, figure on the left to figure on the right. 9 to 16 in terms of their areas. So the area of tulip is 58. I want the area of cobra. So I'm reading it left to right and then left to right. I'm solving for cobra. I know tulip is the 58. So this is what it would look like, or I could switch my variable again and call it something else. Cross multiply, and I have 16x equals 522. Divide that 16 away, and I get that x would be 261 over 8. That's how that would reduce. And then if I made that mixed fraction, I would say 32 5/8. Units are squared. Okay, decimal approximation is fine. So again, what I'm really trying to drive home is that I have two approaches. I can apply a multiplier. So if I'm reading in this direction, I can multiply by that scale factor. I can do that for sides and perimeter. Okay, if I'm going in the opposite direction, I'm multiplying by the reciprocal of my scale factor. And I can do that for sides or for perimeter, but not for area. Area is the scale factor squared. That's my multiplier. So if I was multiplying in this direction for area, right, I would multiply by 9/16. And if I was going in reverse, if I was going from left to right instead, I'd be multiplying by the reciprocal. So I can, again, apply the multiplier or build a proportion. All right, last skill, no pictures, just words. So here we're told that the perimeter ratio of two similar octagons is 7 to 3. The area of the larger octagon is 100 square units. We want the area of the smaller one. Okay, so what is it starting us off with? It's starting us off with the perimeter ratio. And it's telling us that that is 7 to 3. So I know that that would be the same as my side ratio or the scale factor. So if I need an area ratio to solve this problem, I need to square that 7 over 3. So 49 to 9 is my area ratio. Again, I have no picture here. I just have words. So I start off by writing that 49 is 2 9. Just as. Okay. So the area of the larger octagon is 100 square units. We want the area of the small one. So without a picture, I just need to be conscious of where do I have my small number? Where do I have my large one? So since I'm stacking it as large to small, over here it needs to be large to small. I know my large is 100, so 100 goes on top, and I'm solving for the small. X goes on the bottom. And now I'm ready to cross multiply. So I have 49x equals 900. Divide away the 49. Okay, this would be simplified. But if I make that a mixed fraction, I would say that it's 18 and 18/49 units are squared. Okay, as a decimal, I could say it's about 18.37 square units. Okay, and then one more problem. Here I'm giving you the area ratio of two similar hexagons, so I'm starting you with the area ratio. I'm starting you with a squared to b squared. So area ratio, I'm just going to mark that down, is given as 36 to 49. What am I solving for here? The perimeter of the small hexagon is 250 units. Find the perimeter of the large hexagon. Okay, so I need a perimeter ratio. So if this is a squared to b squared, I need to take the square root of 36 to 49, which is taking the square root of 36 and also 49, and I see that it's a 6 to 7 ratio. So my scale factor would be 6 to 7. All of my sides would be 6 to 7. My perimeter is 6 to 7, right? Area is different. Area is that scale factor squared. So I've gotten my appropriate ratio. I've gotten my perimeter ratio. I know it's 6 to 7. The way those numbers are stacked, right? I don't have a picture, so I need to read it as small to large. The perimeter of the small hexagon is 250. I want the large one. So small to large, small to large. So 250 on top and x on the bottom. Okay, cross multiply. So 6x equals 1,750. Divide each side by 6. Reduce it down. 875 to 3. I'll take it like that. I will take it mixed. So 291 2/3 units. As a decimal, we'd say that it's about 291.67. I will take it either way. All right, that's all I got. Have a good rest of your day.